Hey guys, so hopefully you were able to print a copy of the notes from your computer. If not, you can just take notes on your notebook paper for this section. So we're going to talk about graphs as quadratic functions. So your quadratic function is going to come in the form of ax squared plus bx plus c. So your x squared, that's your quadratic term. So if you look at the definition there, it says where a cannot equal 0. That's because if a were 0, we wouldn't have this term here. We'd have 0 times x squared. This term wouldn't exist, leaving us with just a linear equation. So anytime you have a quadratic, you're always going to see that x squared. You may not have b, so you might not have an x to the first power, so you won't have a b, and you might not have a constant. In this entire chapter, anytime we're referring to a, b, and c, we're referring to a being the coefficient of x squared, b being the coefficient of x, and c being our constant. Okay, and then just looking at your vocabulary there, a parabola, that's what the graph of your function is. It makes the parabola, and that's a U-shaped curve. It looks like that. That's a parabola. Okay, your vertex, that's the lowest or the highest point on a parabola. So your vertex for this parabola is right here. Okay, and then your axis of symmetry, the line that divides the parabola into two mirror images and passes through the vertex. So your axis of symmetry is not really part of the graph, it's an invisible line. So when we draw it, we always draw it with a dotted line. But it's an axis of symmetry. And just as the words suggest, it's a line of symmetry. If you would fold along that line, then this side of the parabola would line up on this side of the parabola. And then you have maximum and minimum values. When a is less than 0, so basically when a is negative. So if you had a negative 2x squared and you had a negative out in front of your x squared term, no matter what follows, I know because this is negative, my parabola is actually going to be upside down. It's going to be like this. So we say that this parabola has a maximum value, but it has no minimum value. And if you think back to whenever we were talking about domain and range, this range, my y values, these are going to go to negative infinity and go forever. So you can't tell me how low this goes. But once we find out what our vertex is, you will be able to tell me how high it goes. So we say that anytime a is negative, less than 0, then you're going to have a maximum value on your parabola. If a is positive, if I had like a positive 3x squared, no matter what follows, my parabola is right side up. Again, thinking about the range of a function, this is a low point. You can tell me how low it goes. You can tell me the minimum value here. You wouldn't be able to tell me the maximum because these are pointing toward positive infinity, so it goes forever, never stops. So, a little silly way to remember this. Positive number out front. Positive people are happy, they smile. So your parabola is going to be in the shape of a smile. Negative people, they may frown. So if you have a negative number out front, your parabola is going to be upside down and look like a frown. So maybe it's a little corny, but it's a good way to remember the direction that your parabola is going based off of the sign on the coefficient. So let's go ahead and do this first example here. You have your steps for graphing your parabola. Are there in your notes? Let me erase this. So when you go to graph your parabola, the very first thing you want to do is find your axis of symmetry. So your axis of symmetry is the line x equals negative b over 2a. So the first thing you want to do is find the axis of symmetry. It's a vertical line, so it should make sense that it's x equals because anytime we draw an x equals line, they're vertical lines. So for our example, we're going to be using y equals 3x squared plus 6x minus 1. This is a this is B, and this is C. So when I go to find my axis of symmetry, it's the line x equals negative b over 2a. And here's where I get those numbers. So it's going to be negative 6 over 2a. So 2 times 3. So that's going to give me negative 6 over 6. So my axis of symmetry is going to be at the line x equals negative 1. The next thing you're going to do is you're going to find and plot the vertex. So under step 2, you'll see it says find and plot the vertex. So vertex. Well, you already have half of the vertex because the vertex and the axis of symmetry are going to be the same number when you do the x coordinate. So once you find your axis of symmetry, that is the x coordinate of the vertex. Once you know that, anytime you're evaluating a function or an equation, if you know what x is, in order to find the y that goes with it, all you have to do is plug it into the equation. Plug the x coordinate in. So we're going to take our original here, 3x squared plus 6x minus 1. We're going to substitute negative 1 for all those x's. So y equals 3 times negative 1 plus 6 times negative 1 minus 1. And then, whoops, don't forget your power of 2. All right, so now we just go ahead and figure this out. You're going to use your order of operations. You're going to square this negative 1 first. This is going to go positive. So this is just 3 times positive 1, which is 3, minus 6, minus 1. 3 minus 6 is going to give me negative 3, minus 1 is going to give me negative 4. So y equals negative 4. So you can go up to your ordered pair that you started, and there's your vertex. Step 3 says to plot the y-intercept. Well, if you remember how to find a y-intercept from our last section, all you do is you put 0 in for all your x's, and then it turns out to be just the constant. So let's look at the equation again. If I put a 0 here, this turns to 0. If I put a 0 here for this x, this turns to 0. So the only thing that would be remaining would be this constant right here. So it's at 0, negative 1. So your y-intercept is always sitting at 0c. 0c. It's always there because anything with an x in it is going to just disappear. There's my y-intercept. Okay, and then the last step, or the fourth step, says to find 2 more points. So at this point, I like to graph it first so I can see what point I might want to find. I'll just draw an axis here. Draw in your axis of symmetry first. So my axis of symmetry is at x equals negative 1. So you come back to your graph, x equals negative 1. Here's my negative 1. So you should want to draw a dotted line through there. Plot your vertex. If you did it right, your vertex is sitting on the axis of symmetry. So I'm going to go to negative 1, negative 4, and I'm going to plot my vertex. The next thing we're going to do is plot my y-intercept. Y-intercept is at 0, negative 1. So I'm going to go to 0, negative 1. plot my point, and then I'm going to reflect that over to the other side. So this y-intercept is 1 unit away from my axis of symmetry, so I'm going to go 1 unit to the other side. In order to graph these, you want to have at least 2 points to one side of your axis of symmetry. I have 1 point. So I'm just going to make a little t-chart and pick an x value. Looking to the right of my axis of symmetry, I already know what's happening when x equals -1 because I have a point here. I know what's happening when x equals 0 because I have a point here. So I'm going to go ahead and pick +1. And like I stated before, if you know what x is and you want to find the y that goes with it, all you have to do is plug it in. So y equals 3 times 1 squared plus 6 times 1 minus 1. So y equals 3 plus 6, which is 9, minus 1 is 8. So y equals 8. So that just gives us another point to plot. So I'm going to go ahead and plot that point. 1, 8, 1, 2, 3. And since this point is 1, 2 units away from my axis of symmetry, I'm going to go 1, 2 units to the other side to plot its reflection, and then you can go ahead and graph your parabola. So it's not very neat, but hopefully you get the idea. So that's example 1. Example 2, we're going to do the same thing. So example 2, f of x. So remember, f of x and y are the same. F of x is y. So going in order, find your axis of symmetry. If it helps, go ahead and label these. This is A, this is B, and this is C. So we're talking about just the coefficients. So your axis of symmetry, x equals -b over 2a. So it's -b. Now my b is already negative, so don't forget you're going to flip the sign. So you're taking the opposite. 2a, so it's 2 times -2. So this is going to turn into a +4 over a -4. So this is going to give me a -1. So my axis of symmetry sits at x equals -1. Find your vertex. We already have the x-coordinate because we have the axis of symmetry. So we want to find the y-coordinate that goes with it. So I'm going to just take my f of x and write it as y. So y equals -2x squared minus 4x plus 3, but I want to evaluate that when x is -1. Okay, again, follow your order of operations. You're going to square this -1 first. It's going to go positive. So this is -2 times +1, -2. -4 times -1, +4, plus 3. -2 plus 4 is 2. 2 plus 3 is 5. So my vertex is at -1, 5. My y-intercept is another good point. It's always at 0, C. So for this one, it's 0, 3. Now we're ready to start graphing. plot your axis of symmetry. X equals -1. Plot your y-intercept. I'm sorry, plot your vertex, -1, 5. Plot your y-intercept, 0, 3. Reflect your y-intercept. So my y-intercept is 1 unit away from my axis of symmetry. I go 1 unit to the other side. Okay, so we have 1 point to either side. So when we go ahead and pick another point, we really only need 1 more because we want to have at least 2 to one side. So I know what happens when x equals 0. Let's do x equals +1. So we're just going to take this original equation and we're going to plug in a 1. So y equals -2 times 1 squared minus 4 times 1 plus 3. So this is -2 minus 4 plus 3. -2 minus 4 is going to give me a -6 plus 3 is -3. So that's the y coordinate that goes with my x coordinate of 1. So we go ahead and plot that, 1, -3. That is 2 units away from my axis of symmetry. So I'm going to go 2 units to the other side and make another dot. And then draw your parabola. There we go. So this parabola is upside down. If you notice, the coefficient of x squared was negative. The first example we did, the parabola was right side up and the coefficient of x squared was positive. So you should see the connection there, hopefully. Okay, go ahead and try the next one. We will talk about maximum and minimum values next time. Have a nice day.